Hello everyone, welcome to my channel. This is Dr. Fan. Projectile motion is a very important type of questions in AP Physics. And today, let me use some practice problems to demonstrate how to calculate the launching angle in projectile motion. Alright, let's get into it. Let's say a ball was kicked into the air, and at its peak, the ball lost half its speed. So the question asks us to find the launching angle of the ball under this situation. Many of the students may be clueless when they first look at the question, but that's fine. Let's try to evaluate the physics situation first. The key information is at its peak, the ball lost half of its speed. We know at the peak, the ball do not have any vertical velocity. At the peak, the ball only have horizontal velocity. That's one key information. So the question basically says, if I know my initial velocity is v0, at the peak, my velocity becomes half v0. That's what the ball lost of half its speed at the peak means. Okay, so how this relationship can help us to find the launching angle? We know for the projectile motion, we can decompose the motion into horizontal motion and vertical motion. And if I'm using a different color, I can have my horizontal velocity and I can have my vertical velocity here. We know that along the horizontal direction, the velocity does not change. In other words, my initial horizontal velocity right here and my horizontal velocity at the peak right here, they are the same. So basically then I know my initial horizontal velocity also equals to half v0. Okay? But from the velocity decomposition, I know my initial horizontal velocity can also be expressed by the launching angle, which is v0 times cosine theta equals to v0x. I know my v0x also equals to half v0. If you compare these two sides, you can see that cosine theta basically equals to half. And we know cosine 60 equals to half, so the launching angle would be 60 degrees. Okay, now let's look at a different question. So this question says a ball was kicked into the air and at its peak, its horizontal displacement is 2 times of its vertical displacement. And under this situation, what is the launching angle of the ball? Alright, after the previous question, this question should not be so hard for us. So let's see what the question says. At its peak, its horizontal displacement is 2 times of its vertical displacement. So let's say this is a peak, and this is my horizontal displacement, and this is my vertical displacement. So I know along the horizontal direction, I have constant velocity. So I can see that my delta x equals to v0x times t, because I have constant velocity. My motion has a constant velocity. And along the vertical direction, it's not constant velocity, it's constant acceleration, and the acceleration is g going down. But we can write my vertical displacement equals to the average vertical velocity times t. And how do I find my average vertical velocity? I know my initial vertical velocity is v0y right here. And I know at the peak, my vertical velocity becomes 0. So the average vertical velocity from here to here would be v average equals to half of my initial vertical velocity, your vertical velocity here, plus 0, my vertical velocity at the peak. So that means my average vertical velocity is half v0y. If I substitute this quantity into this equation, I will get half v0y times t. That is my vertical displacement. All right, so the question says the horizontal displacement is 2 times of its vertical displacement. That means delta x equals to 2 times delta y. So if I substitute this delta x and this delta y into this equation, let's see what I get. I get v0x times t, which is my horizontal displacement, equals to 2 times my vertical displacement, which is v0y divided by 2 times t. And if you simplify this equation, you can see that your v0x and v0y are basically the same. So what does this mean? That means if this is my initial velocity, this is my v0x, this is my v0y. This horizontal component and the vertical component, they are the same. And this would be my launching angle. And from trig, we know that tangent theta equals to v0y divided by v0x. And we know they're the same, so that means tangent theta is 1. So that means my theta is 45 degrees. In other words, the launching angle for this question would be 45 degrees. Alright, so let's summarize what we have discussed today. So the key thing we have discussed is that your 2D projectile motion can be decomposed into a vertical motion and a horizontal motion, and both of them are 1D kinematics. And along the horizontal direction, you have constant velocity. Along the vertical direction, you have constant acceleration, basically a free fall situation. And don't forget, your vertical velocity is always 0 at the peak. That's the key thing we have discussed today. I'm going to leave one question to you guys for you guys to solve it when you have time. And I'm going to see you guys next time. Thank you.